are equipped with an electromagnetic clutch as part of the compressor pulley assembly. The clutch is designed to engage the pulley to the compressor shaft when the clutch coil is energised. The role of the clutch is to transmit power from the engine to the compressor and to provide a means of engaging and disengaging the refrigeration system from engine operation. The clutch is driven by one or more of the drive belts fitted to the engine. When the clutch is engaged, power is transferred from the pulley to the compressor shaft by the clutch drive plate. When the clutch isn't engaged, the compressor shaft doesn't rotate and the pulley rotates freely until re-engaged. The clutch allows the AC system to be controlled by an electronic circuit. This can be done by a ground in the ECM and a relay. They may also have a suppression diode fitted to eliminate back EMF voltage spiking the circuit. The clutch coil doesn't rotate when the AC system is in operation. The pulley assembly is magnetised by the stationary coil on the compressor body. This engages the clutch to the clutch hub attached to the compressor shaft, creating refrigerant flow within the system. When the AC switch is pressed, the climate control or HVAC module sends a request message to the ECM via serial data. If all the sensor input conditions are met, the ECM then grounds the air conditioning compressor clutch relay coil control circuit. This closes the contacts within the relay. Voltage is now sent to the compressor clutch coil. Once the cabin has obtained the desired temperature or pressures have been met, the voltage supply ceases and the magnetic clutch is released. In some different model compressors, the clutch is always engaged and the flow of the refrigerant is made possible with a variable displacement solenoid within the compressor. A PWM signal is sent to the solenoid in order to control the displacement. The performance of the AC compressor is regulated based on the cooling load. So, walking to the front of the vehicle and looking down at the compressor to see if it's working is not confirmation of a correctly operating system. P0645, P0646 and P0647 are just some of the compressor clutch relay control circuit codes. These equate to control circuit malfunction, control circuit low, and control circuit high. These codes will set if there's a short to ground, open, excess resistance, or a short to voltage in the circuit. As always, it's important to use a battery maintainer when working on any voltage critical circuits. Always check for any related DTCs or freeze frame data. In some cases, a fault code can set and cause the air conditioning to cease operation. Knowing the recommended data values will help in successful diagnosis. A quick test to eliminate the clutch is to disconnect the voltage supply at the magnetic clutch coil and place a meter on volts between the two terminals. With the engine on and multimeter displaying battery voltage, we can confidently say that the power supply, ground, and circuit are serviceable. This would mean the fault would be the compressor clutch coil. We should test this to further confirm your diagnosis. Place the black lead on the body of the compressor and the other probe on one of the clutch connector terminals. Then place the meter on ohms. If any reading is displayed, there is a short to ground in the compressor clutch. If there was no reading displayed, move the other meter lead to the second clutch connector terminal and watch the display. If there was still no display on the meter, there is an open in the compressor clutch coil. It's a good idea to check with the manufacturer's specification for the clutch coil resistance, as this will further eliminate an excess resistance fault. If initial testing showed no voltage, or less than required across the harness connector, further diagnosis of the control circuit is needed. Check for power at the voltage supply fuse and make sure there's no open. If the fuse was blown, we would need to find the excess current draw. As soon as we know the circuit fuse is in a serviceable condition, we will need to move down the line and check the relay to make sure the control and load circuits are intact. When removing the relay, remember to use a pair of relay pliers. Failure to do so may result in spread terminals, causing more faults within the circuit. Not all relays have the same pin layout, so it's always good practice to consult the wiring schematic for the correct terminal location to avoid misdiagnosis. With the ignition off, using a multimeter, confirm battery voltage is seen at terminal 30 and ground. If less than battery voltage is seen, check the connectors for terminal tension and corrosion. If any abnormalities are found, repair these before proceeding. If no voltage was seen, check the relay supply circuit for opens, shorts, and excess resistance. For more information on relay circuit testing, be sure to watch our video on automotive relays. Turn the ignition on and confirm voltage is present at terminal 85 of the compressor clutch relay. If considerably less than battery voltage is found, check for terminal tension and corrosion at any connectors in the ignition supply circuit. If no voltage was found, further diagnosis of the ignition supply circuit will be required. Now that we have confirmed the ignition and battery supply voltage is present, we will now need to test the ECM's ability to ground the control circuit. In most new vehicles, these relay circuits will be monitored for faults. If we remove a relay to test the control circuit, the ECM will think there is a problem and will disable that circuit, making any diagnosis impossible. This is why we should use a relay jumper. This way, the relay is still in the circuit and we're still able to perform accurate testing. Place the meter leads between battery positive and terminal 86 of the relay jumper. With a scan tool or engine running and the HVAC controls, turn the AC on and off and watch the meter display. The meter should display battery voltage when the AC is requested on and drop to 0 volts when the AC is commanded off. If the meter displayed 0 volts, there may be an open or short to voltage within the circuit. If the meter displayed battery voltage at all times, there is a short to ground in the circuit. Move the meter lead from battery positive to battery negative and watch the meter display. If battery voltage is seen, we have a short to voltage within the circuit. If there was still no meter display, move the lead back to battery positive and the other from the relay jumper and back probe the control terminal of the ECM connector. Again, operate the AC clutch with either a scan tool or with the engine on, pressing the HVAC controls. If the correct voltage is now seen, we have an open in the control circuit between the relay and the ECM connectors. If a short to voltage was determined when testing the control circuit, turn the ignition off and disconnect the ECM. With the meter connected between relay jumper and battery negative, turn the ignition on and watch the display. If any voltage is displayed on the meter, the short to voltage is within the harness or relay. Remove the relay while watching the meter. If the voltage disappears, the short to voltage is within the relay. If voltage is still present, the short to voltage is in the harness between the relay and ECM. If when you disconnect the ECM, the meter voltage dropped to 0, then the short is in the ECM or a circuit from the ECM. To determine where the short is, perform a continuity test between the control terminal and all other terminals in the ECM connector. If continuity is not seen, the short is in the ECM. If initial control circuit testing with the meter connected between battery positive and the relay jumper revealed a lower than desirable voltage, there may be excess resistance in the circuit. Move the lead from the relay jumper and back probe the control terminal at the ECM connector. Then operate the clutch coil control circuit. If the correct voltage is seen on the meter, then the excess resistance is between the ECM connector and the relay. If the correct voltage still isn't seen, turn the ignition off and disconnect the ECM connector and inspect for poor terminal tension or corrosion. If no fault is found here, the excess resistance is within the ECM. If initial testing revealed a short to ground in the control circuit, turn the ignition off and disconnect the ECM. With the meter connected between the relay jumper and battery positive, watch the display. If voltage is still seen, remove the relay while watching the meter. If the voltage dropped to 0, the fault is in the relay. If the voltage remained high, the short is in the harness between the relay and the ECM connector. If when disconnecting the ECM harness connector, the meter dropped to 0, then the short is in the ECM. A fault in the load circuit will cause the compressor clutch not to operate when commanded on. With the AC switched on and the relay jumper still in place, confirm battery voltage is present at terminal 87. If so, we know the relay is functioning as designed. If battery voltage is present all the time, there is a short to voltage within the circuit. Remove the relay while watching the display. If battery voltage disappears, the short is in the relay. If battery voltage remained on the display with the relay removed, the short is within the harness and the compressor clutch coil connector. With the meter connected between battery negative and the relay jumper load terminal and commanding the AC on, we should see battery voltage displayed. If significantly less than battery voltage is seen, there may be excess resistance in the relay or connector. Remove the relay and inspect for terminal tension and corrosion. If this is okay, replace the relay. If 0 volts was found, there might be an open or short to ground in the load circuit. To differentiate between the two, move the meter lead from battery negative to battery positive and watch the display. If the meter displays any voltage now, there is a short to ground in the circuit. Remove the relay while watching the display. If the meter now shows 0, the short is in the relay. With the meter connected between the relay jumper load terminal and battery negative, and a short to ground ruled out, command the AC relay on. 0 volts will indicate an open circuit. Remove the relay and connect a fused jumper between terminals 30 and 87 and watch the meter display. If voltage is now seen, the only possible fault is the relay. If the relay inputs and outputs are confirmed as okay, we will now need to test the harness between the relay and the compressor. Disconnect the compressor and check for battery voltage at the supply terminal and battery negative. If the meter displays battery voltage, this confirms a fault is in the ground circuit. This will be either an open or excess resistance. Place one meter lead on battery positive and the other on the ground terminal of the compressor harness connector. If less than battery or no voltage is seen, check all ground points for corrosion and tension. If this is okay, the excess resistance or open is in the harness. If the meter displayed 0 or less than battery voltage when checking between the compressor harness load terminal and battery negative, there will be an open, excess resistance, or short to ground. To rule out a short to ground, move 1 meter lead to battery positive and watch the display. If any voltage is seen, there is a short to ground between the relay and the compressor connector. With a short to ground ruled out and no voltage displayed between battery negative and the compressor supply terminal, an open will be the fault. If less than battery voltage is seen when connected between the compressor harness load terminal and battery negative, there will be excess resistance in the harness. Having the skills to correctly test an air conditioning clutch circuit, makes diagnosing easier and less time consuming. Thanks for watching. See you soon.